In this video, we're going to look at percentage yield. When we calculate reacting masses using balanced equations, you may have noticed the phrase, calculate the maximum mass of a particular substance. For example, in this reaction, the RFM of magnesium oxide is 40.3 and the RFM of magnesium chloride is 95.3. The molar ratio of the two substances in the balanced equation is 1:1. So we can deduce that if we react exactly 40.3 grams of magnesium oxide with excess hydrochloric acid, then the maximum possible mass of magnesium chloride would be 95.3. That would be representative of a reaction with a yield of 100%. All of the magnesium oxide turned into magnesium chloride and all of it was purified and obtained at the end of the reaction. But in reality, percentage yields are very rarely 100%, and we'll look at some of the reasons for this later in this video. The equation for calculating percentage yield is simply the actual mass of product obtained divided by the theoretical maximum mass and multiplied by 100 to turn it into a percentage. The theoretical maximum mass is what we've been calculating all along when we do equations involving balanced equations and reacting mass calculations. Let's look at an example calculation. In this reaction, we're trying to produce the ester ethyl ethanoate, and we're told that we have 1.15 grams of ethanol and 1.50 grams of ethanoic acid. So very good practice to write the masses underneath the substances, make sure that you recognize them. You did come across these at GCSE. Ethyl ethanoate, we're told that the mass obtained is 1.30 grams. So that's my actual mass. So I'm going to use the masses of the reactants to work out what is the theoretical maximum possible mass of ethyl ethanoate I could make. Since I've been given both of the masses, I also need to determine if either one of them might be the limiting reagent. So I'm going to need to do a mole calculation for both the ethanol and the ethanoic acid. So I'm going to work out my RFMs. My RFM of ethanol is 46, so I'm going to do 1.15 over 46. My RFM of ethanoic acid is 60, so I do 1.5 over 60. That gets me my moles of both substances. Now it turns out that both of the moles are exactly the same. I have 0.025 moles of each compound. This means that the maximum moles of ethyl ethanoate I can make is 0.025 moles. I can use either of those. Everything in the equation is a 1:1 ratio. So the next thing I can work out, if I know my maximum moles of ethyl ethanoate, is I can work out my maximum mass. And so I need to find the RFM, which is 88, is going to be moles times RFM, so it's 0.025 times 88. And my maximum mass is 2.20 grams. I now need to put that into my percentage yield calculation. So percentage yield is going to be my actual mass, which is 1.3, divided by theoretical maximum 2.2 times 100, and that is equal to 59% as a percentage yield. This is the second example that I've included because it's quite a common situation to get in an exam question, and sometimes the hydrated crystal part can throw people. So this is a method you've actually seen before of making hydrated salts, of just making salt crystals generally. So there's the formula of the hydrated salt, and I'm going to need to use that when I work out the maximum possible mass. It's told we made this by reacting excess magnesium powder, so it doesn't matter how much magnesium I've got, I don't need to worry about that, with sulfuric acid. So if magnesium is in excess, sulfuric acid must be my limiting reagent. That's going to determine my maximum mass that I can possibly get. It then says after filtering off the magnesium, unimportant for the moment, we then have our solution. So we filter our magnesium, we get this solution of aqueous magnesium sulfate. Now, of course, that isn't anything that we can weigh because it's in not crystals, it's in solution. So what happens is we then heat that off. We evaporate the water and we obtain hydrated crystals. So during that process, the aqueous magnesium sulfate is going to combine with those 7 water molecules to make my hydrated salt, which is a solid and has that formula there. So how do I answer this question? Well, it tells me 0.02 moles of sulfuric acid were used. It's been quite nice and giving you moles and not mass. And 3.84 grams of hydrated salt. So that is my actual mass of salt. So I will come back to that at the end when I do the yield calculation. So looking at the equation, magnesium sulfate, it doesn't matter whether it has the waters with it or not for the moment. For the purposes of moles, H2SO4 and the product, magnesium sulfate, are in a ratio of 1:1. So I need 1 mole of sulfuric acid to make 1 mole of magnesium sulfate. That means that my maximum possible moles of MgSO4 is going to be 0.020, which means that by extension, because it's all 1:1 in the second equation as well, that my maximum number of moles of the hydrated salt is also going to be 0.020. Now all I need to do is do what we did before, which is work out my maximum mass of the hydrated salt. So I need to do a little bit of working out to do the RFM. So I'm going to work out MgSO4 first. That adds up to 120.4. I'm going to work out H2O is 18, times it by 7 is 126. That gives me my MR, which is equal to 246.4. My mass, therefore, maximum mass is going to be equal to moles times MR 0.02 times 246.4. My maximum mass is therefore going to be 4.928 grams. Now I go back to my yield and my actual mass that's given. So my final calculation for percentage yield is going to be actual mass, which is 3.84, over theoretical maximum 4.928, times by 100, which equals 77.9%. There's my percentage yield. So why is it that some reactions don't have 100% percentage yield? And these are the kinds of things that might be added on at the end of your calculation question. So one of the reasons is that it may be a reversible reaction. You should be looking out for equilibrium reversible reaction arrows in this case. So for example, in our ammonia example, that doesn't reach 100% yield because it reaches equilibrium. And what you would say therefore, for a reaction that reaches equilibrium and is reversible, it does not go to completion. So that would imply that it doesn't really matter how long you leave it, you'll never make 100% products. Some of your products will always be going backwards and turning back into reactants. However, this doesn't actually apply to many reactions we carry out in the laboratory. The first one that I showed you in this video of ethanol and ethanoic acid making an ester is one of those examples, and some organic reactions are at equilibrium, but a lot of equilibrium reactions are sort of high pressure gas reactions that we're not going to be doing under normal situations. So preparation of the salt is not a reversible reaction. Things like that, we can't use that explanation. So what can we use? We can talk about how we get the product out. So normally percentage yield is the mass obtained. It doesn't mean that we didn't make 100% of our product. It simply means that we weren't able to fully separate and purify it. So if we think about our example of adding like the magnesium to the acid, you're transferring to different apparatus. For example, you may have a beaker or a conical flask, and then you're pouring it through a filter funnel into something else. Some of it may stay in the flask, or indeed be left behind on the filter paper when you filter out an excess. And then for hydrated salts, because you have to leave some solution, you can't boil your salt dry, you can't evaporate all the water. And you have to do that in order to get decent hydrated salts. But if you were to look at the liquid around, say, your nice blue copper sulfate solutions, you might see that it's quite blue, and that's because some of that salt, copper sulfate or magnesium sulfate, whatever you've made, is still left in solution, so it doesn't all form crystals. Finally, you may sometimes see marks awarded for saying that the reason you didn't get 100% yield is that your reactants were not pure, or that they were perhaps contaminated, so maybe you had something else present. That, however, is often not accepted, so leave that as a last resort and try to refer mainly to the practical procedure and places where you may have left some of your product behind. So if you want some more help with your A-level chemistry calculations, I've got a full online course, which actually this video was modified from. It's called Confidence in Chemistry Calculations. And at the moment, you can get that absolutely free for 2 weeks. Let me just show you what's in the course. So there are 8 different modules which look at the essentials, equation skills, relative atomic mass, formula mass, empirical molecular mass, percentage yield, atom economy, all these different things. Titrations, loads of stuff on solutions, calculations, also Avogadro, and long answer problems. So there are some like really more challenging ones, and it comes with a full booklet of different chemistry calculations with full mark schemes and explanations as well. All of the more difficult questions that I put on there have video walkthroughs, so you don't just get a mark scheme, you actually get how to do it. Each one of these modules has like at least 6 different lessons in it, quizzes and ways to assess yourself. And actually you can access this course as part of my A-level revision memberships, which includes loads of other different topic videos and practice questions, and not just the calculations course. So the calculations course is included in the bronze, silver and gold membership. The only difference between the 3 of these is that with the silver membership, you get a full monthly assessment where you do an assessment exercise and I mark it for you, give you that examiner's perspective, give you personalized recorded feedback. And with the gold membership, there's just a few spaces left for my AQA and OCRA group chemistry lessons. Those are for year 13 because my year 12 course is full. But if you just wanted to try out the bronze membership, which is only £5 a month anyway, including the whole calculations course and 22 other different topics, along with practice questions and masterclass videos, that's actually available right now for a 2-week free trial. So you can try it, see how you get on, and if you can't even afford the £5 a month, you could sign up if you've got like a mock exam or a retake coming up. So go to my website, ckchemistry.co.uk. You'll also find loads of free revision downloads there as well. And of course, subscribe to my YouTube channel, because I'm going to do at least one video a week and probably two for the next term or so.